Hi everyone, today we're going to be taking our notes over tree diagrams, counting principle, and factorial. So this is going to be after the independent and dependent notes that we glued in our notebook yesterday, and so let's get started. Tree diagrams are used to display possible outcomes and count possible outcomes. Okay. So for tree diagrams, it's more like categorical. And so here's an example. The school cafeteria sells sandwiches for which you must choose one item from each of the categories. 2 breads, white or wheat, 2 meats, turkey or ham, and 2 condiments, ketchup or mustard. Create a tree diagram to show all possible choices. So here's our 2 categories, white bread and wheat. And so from the white bread, we can choose 2 meats, which is turkey and ham. And same for wheat. We can choose turkey or ham. So what the tree diagram does is it gives us more like a display of those outcomes from the choices, okay? And then we have mustard or ketchup. And so if we chose turkey, we could choose mustard or ketchup. I'm just going to abbreviate. And then if we choose ham, we can choose mustard or ketchup. Same for if we chose wheat bread and we went with turkey, we can choose mustard or ketchup. And if we went with ham on wheat bread, mustard or ketchup. Okay? All right. And so if we count all these outcomes visibly, we can see there's 1, 2, 3, 4, 5, 6, 7, 8. But we should all know that a quicker way to do that is just multiply each category. So 2 times the 2 breads that we have are white and wheat. The 2 meats are turkey and ham. And then the 2 condiments are mustard and ketchup. So 2 times 2 is 4 times 2 equals 8 different sandwiches. Okay. And so tree diagram again is just to see that display. Different sandwiches. Okay. All right, the counting principle is just that if there are an n amount of ways of making one choice and m amount of ways of making a second choice, then there are n times m ways of making the first choice followed by the second choice. So this is generally used when a tree diagram is too large to construct. So again, we just multiply. Here's an example. You have 7 shirts, 3 pairs of pants, 2 belts, and 3 pairs of shoes to choose from. How many different outfits could you create? And so we just multiply all those outcomes. 7 times 3 times 2 times 3. Okay. And that would be 3 times 2 is 6 times 3 is 18. 18 times 7, 126 outfits. Okay. Now, we have seen this before in our warm-ups, and so this might be just a review for you if you did your warm-ups previously for probability. All right, example 2. You're choosing a computer password. The password has 3 letters followed by 3 digits. How many passwords are possible if the letters must be uppercase? Okay. So we have, it needs to be 6 characters, right? 3 letters and 3 digits, so 6 characters total. Okay, how many passwords are possible if the letters must be uppercase? All right, so for the letters, how many letters are in the alphabet? Do we know? There are 26 letters, so for the first letter, there's 26 possibilities, okay? And then for there's 3 letters, so we need to do that 3 times. 26 times 26 times 26. Again, why 26? Because there's 26 letters in the alphabet. Followed by 3 digits. Now, for digits, we can be any number from 0 to 9. And so that's a total of 10 digits that we could choose for the next 3 characters. Okay? And so we multiply all of those numbers. It's a pretty big number. There are 17,576,000 possible passwords. Okay. All right, so that's another example for the counting principle. Let's keep going. How many passwords are possible if no letter or digit can be repeated and the letters have to be lowercase? Okay, so the lowercase and uppercase doesn't really matter. It's just extra information. And so when it's cannot be repeated, this is when the outcome changes. So if I choose my first letter, I have 26 possibilities that I can choose from, right? But then when I choose the second letter, I can't choose the letter I already used for the first character. So then it goes down by 1. So 26 goes down to 25, sorry, about 26. 25. Because I can't repeat the letter, okay? And so then the next number would be 24 following that. And same for the digits. So if there's 10 possible digits I can choose from, but now they can't be repeated, 10 goes down by 1, and now it's 9. And then down by 1, it's 8. And so that changes things. Okay, so now it's only 11,232,000 possible outcomes. Possible passwords. Okay. So pay attention to the wording, and then you can calculate. All right, let's keep going. All right, factorials. Factorials are very important. We will be seeing this tomorrow as well. And so what is a factorial? A factorial of a number is that number multiplied by every positive integer before it. Okay, and I will give you an example of that right now. Okay. All right, so that means if I have 4 factorial, this is equal to 4 times 3 times 2 times 1. That's what it means by every number, multiplied every number, every positive integer before it. So 4 times 3 is 12, 12 times 2 is 24. Okay. The factorial notation is indicated by that exclamation point, so that you see the 4 factorial. That's when you know it's a factorial. So this reads, if you have a number with a exclamation point, this reads n, the number, factorial. So it's not just 4, it's 4 factorial. Okay. N must be a whole number. So not a fraction. In other words, one cannot evaluate like 3.71 factorial. You cannot do that. Okay. All right, and then in terms of order of operations, factorials have equal importance to exponents. Therefore, what is the only thing with more importance than factorials? And that is PEMDAS. Okay, so parentheses. It's also more important, okay? Okay, example 1 is blank, and so for that one, we're just going to write the formula for the factorial, like in terms of n. So n factorial equals the number, and then you multiply the number minus 1, and then the number minus 2, and then you just keep going. Okay. All right, so 0 factorial, this one's very important. This is something you must remember forever. 0 factorial is always 1. Always 1. You just have to remember that and know that, okay? So 0 factorial is 1. All right, 5 factorial, let's do this one. This would be 5 times 4 times 3 times 2 times 1. All right, 5 times 4 is 20, 20 times 3 is 60, 60 times 2 equals 120, okay? All right, what about when we add some division here, which is what you will see tomorrow. When you add some division, you still do the same thing, but it makes things a little bit more detailed. And so 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All of those numbers over 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? Now, if you visually see this, hopefully your brain power tells you that you can cancel some things, because you can. You can cancel 1 over 1, 2 over 2, only because it's being multiplied. 3 over 3, 4 over 4, 5 over 5, 6 over 6, and 7 over 7. And so this just makes our work a little easier, because now we just have to multiply 10 times 9 times 8, since those other numbers canceled out. So 9 times 8 is 72. 72 times 10, 720. Okay. Another way that you could do this, so just do a note here, another way, which is what we'll start doing from now on, I just needed you to see that expansion, is that if you have 10 factorial over 7 factorial, right? When you write that out, and I'm counting down from 10, 10, 9, 8, 7. See how I already see the 7 factorial in the bottom? So I'm just going to stop there, okay? But then when I write the 7 factorial, then I can cancel those. And then I'm left with the same thing. 10 times 9 times 8, 720, okay? And we'll start doing that. But you have to pay attention to that notation. Make sure you do it carefully. Okay, let's keep going. 13 factorial over 16 minus 5 factorial. So first we need to simplify the parentheses. So 13, what is 16 minus 5? That would be 11. Okay, and so let's expand this. 13 times 12 times 11. Oh, 11 factorial. I see it there. So I can cancel those. 13 times 12 is 156. All right, let's keep going. 9 factorial over 13 minus 6 factorial. So that would be 9 factorial over 13 minus 6 is 7. We simplify that parentheses first. And then now I can expand it. 9 times 8 times 7. Oh, 7 factorial. Can cancel. 9 times 8, 72. Okay. All right. 9 factorial over 5 factorial times 4 factorial. Oh, so this is different. Okay. This is different. Here we have 2 factorials being multiplied, okay? And so when that happens, You just expand it the same way. We just get more numbers in our expression. And so I will show you that. So here, you can attack this so many ways, but I'm just going to show you the quickest way that I would do this would be expanding the 9. And so that would start with 9 times 8 times 7 times 6 times 5. And so I know there's a 5 factorial there, so I'm going to cancel the 5 factorial first. Do y'all see here and here? Those can cancel. And then I can draw another simplification. 9 times 8 times 7 times 6. And then I have 4 times 3 times 2 times 1. But the 1 doesn't really do anything. All right, here, what can I cancel? I can cancel, let's see. I can cancel 3 times 2. 3 times 2 is 6. Right? So that's this one. Okay. And then so I just have 9 times 8 times 7 over 4 times 1. Okay. All right. And then we just calculate 9 times 8 times 7. That is 504. Oops, sorry, equals divided by 4. So 504 divided by 4. That reduces to 126. Okay, and like I said, there's so many ways to attack this. You could expand a lot of these numbers into their multiplication factors, and that would help. All right, 12 factorial over 7 factorial and 6 factorial, so 12 times 11 times 10 times 9 times 8 times 7. I'm going to cancel that 7 factorial on the bottom. So cancel those two, and I'm left with 12 times 11 times 10 times 9 over 6 times 5 times 4 times 3 times 2 times 1. Okay? All right, let's see. What can we cancel? 4 times 3 is 12, right? 4 times 3 is 12. Let me get rid of that big number. And then 5 times 2 is 10. 5 times 2 is 10. And I believe that's it for now. I'm just going to keep going. I'm just going to simplify. 11 times 9 over 6 times 1. So 99 divided by 6. Did I do that right? Yes. Did I miss a number? 6 times 5 times 4. No. Oh, I forgot the 8. Sorry. Times 8. I forgot to write down this 8 over here. Okay. So then let me erase this. Everybody makes mistakes. It's okay. If you caught that, thank you. So 11 times 9 times 8 over 6 times 1. Okay, so if we multiply that, 11 times 9 is 99 times 8 is 792 divided by 6. is 132. Okay. All right, this one says this is an example of what you might see today. How many different ways can you arrange the seating of 4 people at a table? So keyword is arrange. So we have a table. Sorry, let me just use my shape tool. We have a table with 4 people. How many different ways can you arrange it? So the first person sits down. All 4 people sit down. Sorry, first person sits down. There's 4 seats. Then the next person goes, now there's only 3 seats. Then 2, then 1. So that would be 4 factorial, type many ways, which equals 24. 24. All right. Okay, make sure you glue this in our next page, which I believe should be 28. And this is going to be our next topic, okay? Thank you.